Good day, students. Welcome to a clip on how to use sum of difference identities to evaluate trig angles. Okay. All right. So let's go ahead and take a look at question number 1. The instructions for the examples are to evaluate the following. Okay. Evaluate the following. Now, you notice I have a unit circle on the right. You're going to need to make use of a unit circle for this clip, okay? All right, so let's take a look at number 1. The first angle we're going to evaluate is cosine 195, okay? Okay, so now what we're going to do is ask ourselves what two common angles on the unit circle add or subtract to give 195, okay? So let me just do a scratch work on the side here. You don't have to write this down. I'm going to test 30, 45, and 60. I can add or subtract this angle to see which of these I get, okay? So let's try 30 first. What is 195 plus 30? 5, 9 plus 3 is 12, 225. Is this a common angle? Let's see, absolutely, 125 is right here, okay? So this is what I'm going to be using. This is the angle. I'm going to be using 225, and I'm also going to be using 30 degrees, okay? So how do we do it? Well, let's set it up. What we're going to have is cosine 195 is going to be, we can rewrite this as cosine 225 minus 30, okay? Cosine 225 minus 30 gives me cosine 195, all right? So there you have it. So this is my first angle, so this is going to be alpha, and this is my second angle, so that's going to be beta. We're going to be using the formula cosine alpha minus beta, all right? And when it cosine alpha minus beta, the difference identity is cosine alpha, cosine beta. The trig functions are the same, but the sign is opposite, plus sine alpha, sine beta. Okay? So let's apply that here. So we're going to have cosine alpha, which is cosine 225, cosine beta, which is cosine 30, plus sine alpha, sine 225, sine beta, which is sine 30. Okay? All right. Now, what are the values of these angles? Well, let's make use of our unit circle ratios. Alpha is 225 degrees, and the coordinates for alpha 225 are negative root 2 over 2 for the x coordinate, and then negative root 2 over 2 for the y coordinate. And then for beta, beta is 30 degrees, and the coordinates are negative root 3 over 2 and root 3 over 2 and 1/2. So root 3 over 2 and 1/2. All right, so this is my x coordinate and this is my y. Using my unit circle ratios, I know that my x coordinate is the cosine and my y coordinate is sine. Okay? So I'm going to be plugging those values into my expression right here. All right, so it's going to become cosine 225, or I can write it, I think I have enough space to write it here. I'll write that here. Cosine 225 is the x coordinate here, which is negative root 2 over 2, times cosine 30 degrees is the x coordinate for beta, which is root 3 over 2, plus, following this plus, sine 225 is the y coordinate of 225 of alpha, which is negative root 2 over 2, and times sine 30 is a y coordinate for beta, which is 30 degrees, 1/2. All right, so let's simplify that. We're going to have, you multiply the radicands here, so they both radicals, negative root 6 over 4, you multiply the denominators across, minus root 2 times 1 is just root 2 over 2 times 2 is 4. All right, so there goes your answer, or you can express this answer as negative root 6 minus root 2 divided by 4. All right, so there goes your final result. All right, let's take a look at question number 2. So for question 2, we want to evaluate sine 105 degrees. Okay? All right, so 105 is not on the unit circle. This is not a common angle. So I need to find two common angles that add or subtract to give me 105, okay? So what we're going to do here, let me do some scratch work on this side. You don't have to write this. I know my common angles, my reference angles are 30, 45, and 60. I know by adding or subtracting one of these to this, I will end up with a common angle. So let's test 30 first. Let's add 105 plus 30. And then we end up with 135. Is 135 a common angle? Absolutely. So we have 135 and 30. The difference of these two will give us 105. All right? So we're going to use that to express sine 105 as, so sine 105, I'm going to write it as sine 135 minus 30 degrees. Okay? So there you have it. All right, so let's indicate what alpha and beta are. Write our difference identities for sine and then apply to this formula, okay? So the first angle that we have is 135, so this is alpha, and the second angle is beta. All right, so we're looking at sine alpha minus beta, the difference identities for sine. So that's going to be sine alpha cosine beta. You switch the trig functions and keep the sine minus sine beta cosine alpha. All right, that's the difference identities for sine. So how does that apply to this problem we're doing? It's going to become sine alpha, which is 135, the first angle, cosine 30, which is beta, the second angle, minus sine beta, which is 30, cosine alpha, which is 135. All right, so what is the value of each of these trig expressions? Well, let's indicate what the have for is. Alpha is 135, okay? And beta is 30 degrees. So these are common angles. I can use my unit circle to figure out what these are. So 135, let's see, what are the coordinates for 135? Negative root 2 over 2 and root 2 over 2. So let's put that down. Negative root 2 over 2 and root 2 over 2. And then for 30 degrees, we already know what that is. 30 degrees right here. Root 3 over 2 and 1/2. So let's put that in. Root 3 over 2 and 1/2. This is my x coordinate, and this is my y. Remember, your x coordinate is your cosine, and your y coordinate is your sine. Okay? All right, so what is sine 135? Sine 135 is the y coordinate of alpha, or 135, which is root 2 over 2. Cosine 30 is the x coordinate of 30 degrees, which is root 3 over 2, minus sine 30 is the y coordinate of 30 degrees, which is 1/2, times cosine 135, which is the y coordinate of 135, which is root 2 over 2. All right, so we're going to multiply these out, and that's going to give us root 6 over 4 minus root 2 over 4. That can be written as root 6 minus root 2 over 4. And there goes your final answer. Okay, wait a minute, I made a slight mistake here. Alright, so the cosine x is negative root 2 over 2, so there should be a minus right here. So when I multiply this minus with this minus, that makes this a plus. So that's also plus. Alright, so that's the correct answer. Sorry about that. Alright, so the answer is root 6 plus root 2 over 4. Alright? Okay. Alright, let's go ahead and consider the last question, question number 3. And we're going to evaluate the trig expression cosine 7 pi over 12. Okay? Alright, so this approach is slightly different. What we're going to do is we're going to break down this angle right here, cosine 7 pi over 12. And this is a strategy. I need to think of two numbers that add or subtract to give me 7 and have common factors and that can go into 12, okay? So I'm going to use 3 and 4 because 3 goes into 12 4 times and 4 goes into 12 3 times. So I'm going to use 3 pi over 12 plus 4 pi over 12. Okay? Now notice 3 pi plus 4 pi equals 7 pi over 12. So these two expressions are exactly the same. Okay? So now what I'm going to do is I'm going to reduce these two fractions, and then we're going to end up with two common angles. Alright? So we're going to have cosine. 3 goes into 12 4 times. So 3 goes here once, 3 goes here 4. So pi over 4 plus, now 4 goes into 12 3 times, 4 goes here 1, 4 goes here 3, plus pi over 3. Okay? Now these two are common angles. Pi over 4 is 45 degrees, and pi over 3 is 60 degrees, right? So let's see. Pi over 4 and pi over 3, if you look at the unit circle, you will see pi over 4 and pi over 3. Okay, so these are the coordinates that we're going to be using for this example. Alright, so before we start evaluating trig functions at each coordinate, let's determine what formula we are using. Okay, so this is alpha, the first one, plus beta, the second angle. Okay, so cosine alpha plus beta, we're going to use the sum identities for cosine. Is for cosine, the trig function stays the same. Cosine alpha, cosine beta, but the sign switches. Minus sine alpha, sine beta. Okay? Alright, and then down here we're going to have cosine. Alpha is pi over 4. Cosine beta, which is pi over 3. Minus sine alpha is pi over 4. Sine beta is pi over 3. Okay? So there we have it. Now, pi over, alpha is pi over 4. And the coordinates of pi over 4 are root 2 over 2 and root 2 over 2. And for pi over 3, which is beta, the coordinates are 1 over 2 and root 3 over 2. If you look at the unit circle, that's where I got these coordinates from, okay? Pi over 4 right here, and pi over 3 right there, okay? All right, now let's go ahead and evaluate each. Remember, this is your x. Your x coordinate is your cosine, and your y coordinate is your sine, all right? Do not forget that. Now we're going to apply that to this case. Cosine pi over 4 is the x coordinate of pi over 4, which is root 2 over 2. Cosine pi over 3 is the x coordinate of pi over 3, which is 1/2 times 1/2. Minus sine pi over 4 is the y coordinate for pi over 4, which is root 2 over 2. And then pi over 3 is the y coordinate for pi over 3, which is root 3 over 2. If we multiply them out, multiply the numerator here, you have root 2, the denominator here 4. Minus, you multiply the numerator there, root 6, the denominator here 4. So the answer is basically root 2 minus root 6 divided by 4. And that's your final result. Alright, so there you have it. So thanks so much for taking the time to watch this video. You can feel free to subscribe by clicking up here. If you like this video, you can click like. Please post a comment and tell me what you think. about this video. More videos can be found on mathcodeserve.com. Thanks again and have a wonderful day.